thank you for inviting me to your workshop, and I hope I can give particularly young researchers some ideas here. UC San Diego certainly does not need any lectures about technology transfer. They have that's been long a high priority, including having review boards and consultants, engineering consultants on your research. So the Technology Transfer Committee is really mainly directed at younger researchers that maybe don't understand the process and need some tips. If you're pre-planning a project, obviously research that has been already noted by the industry or standards as something that is needed, that kind of research is certainly going to be more easily implemented. So the question is, how do you find that? Well, I guess the science plan that NHERI has produced was sent out to you. It is intended to be very comprehensive regarding a mitigation of risks or improving resilience related to all the natural hazards covered by NHERI, and of course that includes high winds, tsunami, storm surge, and earthquake. I'm going to concentrate mainly on seismic because this site certainly has that focus. What are some other sources, perhaps, that you could get ideas? All the hazards have research plans of one sort or another. There's some links here that I think you're going to get the slides, so when you get the slides, you can use these links to get this various documentation that I'm going to show. But in the wind, there is a National Windstorm Impact Reduction Program that has a strategic plan. That program is run out of NIST, and so there is a similar thing to the science plan, only focused on wind. The tsunami also has a research plan produced by NSF and NOAA, and you got a link there. And then lastly, there is a Future Issues and Research Needs document that is now available on the Building Seismic Safety Council website, and there's a link there. I'll talk about this document a little bit more, and the NERP provisions that's produced by the Building Seismic Safety Council. So let's talk a little bit more about seismic. The NERP provisions is created every 5 years, and it's a feeder to the seismic provisions of ASCE 7, and the seismic provisions of ASCE 7, that's a loading document. That's pretty much required by the codes. So in a way, that when you produce the NERP provisions, it's directly related to going eventually into the IBC. Only it goes through ASCE 7 first. The NERP provisions is made up of 25 or 30 individuals funded by FEMA. The travel is, of course, the work is all voluntary. So it's really the best place to get seismic research implemented because it's supposed to be far future thinking, and so new ideas and concepts should go through the NERP provisions before it gets to ASCE 7. So at the end of every cycle, 5-year cycle, several documents are published as part of the NERP provisions. We just finished the cycle, so the latest version will be published actually probably within the next month or two. And the NERP provisions is made up of 3 parts. Part 1 is the actual changes that are proposed to be made in ASCE 7 that have been voted on over the 5-year cycle. And then with every change, of course, there's a commentary to that change. So part 2 of the NERP provisions is, in fact, the commentary that is related to those changes. And then part 3 is maybe not so familiar to people. It's called the resource papers, and it documents work that's been done by committee members that, for one reason or another, did not get into a proposal. So in order not to lose that work, this Part 3 was created. And because it's, again, future thinking, those resource papers could contain, you know, ideas for research that is needed. And then lastly, there's this future issues and research needs document, which I'll also talk about a little bit more, that is created by the members of the Provisions Update Committee at the end of every cycle, which documents issues that they've seen come up within the provisions over the last 5 years and research that might be needed in order to solve some of those problems. So the resource paper document this particular cycle is quite long, and these are the subjects of the resource paper. You can see it's quite varied. There's concerns about the current mapping, the risk basis of the current mapping. There were several members that had sort of a minority opinion, so they have written about that. Of course, resilience-based design is a big concern because it would seem to be obvious that eventually something like that is going to have to get in a code, and what is that going to look like? So there is a paper discussing that. It's a pretty comprehensive paper discussing what we know about shear walls and lateral earth pressure and so on. You can see these different subjects, a lot of concerns about diaphragms and lack of testing on certain kinds of diaphragms. So there's probably some good suggestions for research needs in those papers. Now that the other document, the future issues and research needs, is here is the website for that document, and some highlights. Certainly not all of the things that are discussed in there I'm not showing here, but some of the highlights is, again, the concern about functional recovery and parallel sort of design criteria for essential buildings to make sure those buildings will stay operational after an event. We really haven't had a lot of experience with such buildings other than the base isolated ones, so it's really not known whether our design simply with an importance factor of 1.5, what that's going to do. There's a lot of concern about that. Another thing which is pertinent to UC San Diego is that there's a lot of interest in rocking structures, and there's really no design guidance of enough detail that would go into a code, so that is highlighted in this future issues and research needs. There are concerns about the vertical component of ground motion, and that yet is another subject that could take advantage of the new table in combination of the vertical component and the horizontal components. And Joel was talking about also there's a twisting motion that is of concern. That concern many years ago created the accidental torsion part of the code, and that's been controversial whether it's big enough or whether it's needed at all. So that twisting capability of the table might be very useful for that issue. There's a lot of also concerns about duration of ground motion, and certainly in the Northwest, whether our provisions now, which are considering the large earthquakes, but California style, certainly not as long as we're expecting. And there's always problems with the design of non-structural components. This cycle, the forcing functions of the non-structural world were completely redone. A lot of work done by ATC to produce that change, but there's always a concern that is our implementation good enough, and it seems like most earthquakes show us that there's always a lot of damage to non-structural components, so that's always a concern. And interesting, the most common diaphragm that we have, a cast-in-place diaphragm, is actually not tested very much, mainly because I guess everyone thought that it is solid. But in order to put it on an equal basis with other diaphragms been tested, this Future Issues and Research Needs document is calling for some tests of cast-in-place concrete diaphragms. And finally, there's been some studies that show that the non-structural finishes of stud-framed buildings, steel and wood, that has a lot of sheetrock and plaster finishes that are quite strong and stiff, are interacting with the shear walls and might give us unexpected results. And this is both good and bad because the tests or computational tests show that it helps, and the buildings are much stronger than we expect, but on the other hand, it can create a weak story at the ground level because these walls are typically the same on every floor. So you finally get down to the first level, and it will become a weak story. There are many other ideas and needs. I just picked out some. The other assistance for implementation comes from our committee. Actually, that's why we were created. We have made one sweeping view of all research, NEHRI research. We're about ready to embark on another sweep of the research been done in the last couple of years. But we have other programs, so to speak. This is a little flyer here, which I know you can't read, but you can probably read it when you get the copy of the slides. But this basically is advertising the Technology Transfer Committee, and it's sort of aimed at young researchers. And this committee is about 20 volunteer people who are knowledgeable about technology transfer in all of the hazards: tsunami, wind, storm surge, and seismic. So we have sort of experts in all those areas on the committee that could help with the implementation. There's a lot of implementation ideas that are documented in another paper that we've written, and we're actually also offering brief conversations between young researcher or any researcher, as far as that goes, with the Technology Transfer Committee or a member of it to discuss, and I'm talking about maybe an hour or two, but to discuss implementation and how the research might be changed in some way or refined to make it more implementable. So that flyer is available. There's also one of the major efforts was a paper that we've written on the mechanisms for implementation of NEHRI research results. And this paper took a long time and is quite comprehensive. It goes over the common methods for implementing research results, specifically in the hazards area. And there's also some of the members felt that researchers could frame their results in ways that make it more readily implementable, because sometimes you get the research results and there is some intermediate step that has to be taken by somebody or some group that translates the research results into more code type information. So those steps are sort of documented in there. There's an overview of how the existing codes and standards work. It's a mystery to students, I know. It's kind of a complicated world. And in the seismic world, as I mentioned, it goes from the NHERP provisions to ASCE 7, finally to the IBC or the IRC. And we're also discussed, besides ASCE 7, we discuss ASCE SEI 41, which is the code, you might call it, the standard for existing buildings. We also give an overview of research implementation and technology transfer programs of major federal organizations that everyone's heard about, such as FEMA, NIST, and then private organizations such as ATC and BSSC. The NHERP Provisions is actually organized by BSSC with funding from FEMA. We also give some information on privately funded entities that have technology transfer activities. There's a number of these related to house construction. And there's also discussion about early adopters. An early adopter in this sense is most likely an engineering company that knows of some research results somewhere that is not in the code yet, but feels that this information could improve their designs. So they use it before it gets in the code. This particular method sometimes runs into trouble with local building departments, but engineers can often, through peer review or other methods, get their designs approved by early adopters. So if a research has engineers or a panel or a consultant from industry on their team, so to speak, or reviewing their research all the time, those engineers are the ones that are likely to be early adopters because they would be very familiar with the results. There's also some special issues when a research ends up developing proprietary materials, design methods, or construction methods, and we discussed that briefly as well as to how the differences of implementation when there's proprietary information developed. And lastly, we emphasize that presentations of all kinds are useful and necessary because nothing is ever going to get implemented unless somebody knows about it. So it's needed to give presentations on an ongoing basis about the research and the results so that the code or other people are going to implement it know about these results. The paper also stresses what I mentioned to start, that the industry involvement in research on an ongoing basis is very useful, and I know from personal experience that UC San Diego does this very successfully and has review boards and committees that are overviewing their research and making suggestions on how to make it more useful. So this particular paper is also available with this somewhat long, crazy link, but that was assigned by DesignSafe, so I have nothing I can do about that. But you can get that paper from that link, and I hope that the young researchers will avail themselves of that paper, because I think it has a lot of useful information for the young researchers. So thank you for inviting me, and I hope this was useful.